Hello and welcome to another in the Precisely series of ZOS webinars. This one entitled The Other Part of SMS, Storage Management Subsystem Definitions. My name is Steve Pryor. I'm a Principal Technology Architect here at Precisely, and I have a lot of background in SMS. I've been working in SMS for more than 30 years, since its implementation in 1989 by IBM. And I think everybody is pretty familiar, at least with the terms, ACS routines and storage class and management class and so on. But there are actually a number of other sort of pieces to the SMS puzzle that we can talk about. And what I want to do in this presentation is talk about some of these other pieces, and specifically about the SYS1.PARMLIB member of IGDSMSxxS. So let's talk about the components of SMS, or more specifically what IBM calls DFSMS, the Data Facility Storage Management System. There are a couple of pieces that people probably know about. You probably know about the existence of the configuration data sets, the source control data set, or the SCDS, the active control data set, or ACDS, and the communications data set. These are the configuration data sets that hold the SMS configuration. The SMS configuration itself consisting of the four classic SMS constructs, data class, storage class, management class, storage group, that define what the policies are as to how a data set should be created and where it should reside. And then the ACS routines, or the automatic class selection routines, assign those constructs, except for storage group, to a data set. The storage group applies to the volumes, but the data class, storage class, and management class describe what a data set should look like and how it should be handled. The storage group describes the volumes upon which the data set should reside. So those are the classic components of SMS that one thinks of for DFSMS. But there's another important component. It's a SYS1.PARMLIB member. In fact, there are several SYS1.PARMLIB members of importance. IGDSMSxxS, we'll call it 00 here, but it could be, of course, any suffix. IGDSMSxxS describes the SMS configuration options. ALEC00 describes the allocation configuration options, and there's a number of them, and these sort of overlap in their function between the SMS member, the ALEC member, the IGG-CAT00 member, which describes catalog options, and the device support member, which describes hardware options. All of these have their part to play in SMS, but what I'd like to talk about today is IGDSMS member. There are at least 92 separate options that can be specified in IGDSMS. It's one of more than 80 PARMLIB members in SYS1.PARMLIB. And so, pardon me, it's usually the domain of the system programmer to be updating SYS1.PARMLIB and to understand what the SYS1.PARMLIB members do. But for any programmer, it's important to understand, if you're going to be dealing with disk storage at all, or with any sort of storage, what the SMS member does in SYS1.PARMLIB. And within SYS1.PARMLIB, one of the 80 PARMLIB members, there's a very large number of parameters that affect SMS. Most of them are still applicable, although SMS having been around since 1989, a few of them are obsolete. Mostly, you don't need to change the defaults, although there are some that you should probably consider changing. The IGDSMS PARMLIB member is sort of a standard PARMLIB member. The keywords are separated with a blank or a comma. There's no continuation required, and the comments are in asterisk slash asterisk slash pairs. So if we make a change to the IGDSMS member, we may need to activate it in order for it to take place. And there's two ways to deal with making changes to IGDSMS00 before we get into the gory details of exactly what the parameters are that we might change. We can talk about how to change the members. And so there's really two commands, two ZOS commands that can be used. One is the SET command, and it's a little bit confusing because the two commands are very similar in syntax, but SET can be used to update any PARMLIB member. And so if we want to activate a new SMS member, new IGDSMS 00 or 01 or 02 member, then we can use a SET command, which is abbreviated with a T, to start SMS if for some reason it's not started, although normally it always is, and to change all of the SMS parameters that are specified in that member. If there aren't any parameters specified, or if there are some parameters missing, then of course the defaults get used. And you might use this if you wanted to activate a completely new configuration, or if you had a number of values in the IGDSMS 00 member you might want to change. You can specify the SET command, as we see here, SET SMS, in this case, IGDSMS 02. Confusingly, the SET SMS command is also used to change the values of PARMLIB, values that are specified in a PARMLIB member. But the SET SMS command is used to change individual options that are within the IGDSMS 00, that reside within the IGDSMS 00 member. But the SET SMS command allows you to specify those parms individually on the command and then change those values. So if I wanted to specify, for example, that I want to now allow the use of extended addressing volumes, EAV volumes, I might specify SET SMS use EAV equal yes. I might also specify a breakpoint value. In this case, the data set has to be at least 50 cylinders in size before the allocation will prefer the cylinder managed space for a data set that's going to use EAVs. Or I might want to change the value for where I keep my backup copy of the source control data set. I can say set SMS, save SCDS, and I can specify any number of these options on the command, and those options will be in place until the next SET command or until the next IPL. So they don't change anything in SYS1 PARMLIB itself. They're used to override the values that we got from SYS1 PARMLIB when we initially started SMS. Okay, so as we said, there's a lot of different parameters in IGDSMS 00. There's so many, in fact, that we really sort of need to break it down into a bunch of different categories. So we have here a dozen or so different categories. We won't go through every parameter in every category because in that case, this would be a very long webinar. But I want to talk a little bit about the more important ones, those that affect the SMS configuration itself, those that are related to the ACS routines or allocation or data sets, and then there's a bunch of others that are related to components of allocation and ZOS, such as SMS VSAM, VSAM record level sharing, CICS and the coupling facility, and so on. So let's talk about these categories of options in IGDSMS 00. But first, I want to talk about some of the newer PARMs in IGDSMS 00 that have been made available just in the last couple of ZOS releases. So you might not be aware of them. ACS underscore log rights allows you to allows the ACS routines to honor a new statement called log write, which you can put in the ACS routines. And the idea is that for debugging purposes, you can, within the ACS routines, use a log writes statement to write the values of the ACS read-only variables out to logrec. By default, if you put a log write statement in the ACS routines, it's ignored unless you turn on ACS underscore log writes enabled. Another one, and I don't know why this isn't the default, but ACS underscore routine underscore debug, we can turn on or off, or we can turn it on or off for particular jobs. You can say enable and give it a job mask. And this allows the ACS routine write statements to write to the job log for particular jobs where normally they would not. For the write statement in the ACS routines by default is ignored for dynamic allocations. And so it's ignored for TSO. And particularly when you're debugging the ACS routines, you may want to have write statements where you can see the output. And so in that case, you can turn on ACS routine debug enable and see the actual write statement output. It seems to me that you might want to turn that on all the time, but the default is disabled, but you can certainly turn it on for debugging purposes. One that is enabled by default is auto vol status ext pool, which for certain types of hardware, if an ENF event occurs, an event notification facility event occurs when the back end begins to run out of space. This is really a hardware related issue. If you get an ENF event for compression extent out of space, which is a hardware-related back-end issue that says I'm running out of space in the back end. Those volumes that are related to that particular back-end extent can be set to quiesce new status so that data sets will not be allocated new on those devices until that compression extent out of space condition on the back end is relieved. And so that's turned on by default. One that's a little bit, works a little bit backwards from what one might expect is bypass cluster preferencing, which says, and the default is don't bypass cluster preferencing. That is, do prefer, if I'm allocating data sets, to get volumes in the same flash copy cluster. If you never use flash copy or running into problems with flash copy, you might want to bypass cluster preferencing, turn it on to yes, but normally there's no reason to fool with it unless you're having some sort of flash copy issue. So let's talk about some of the other PARMs. We can, again, break these up into categories, so we can talk about the configuration parameters. The only thing that's really required in IGDSMS is the name of the ACDS, the active control data set, where the configuration resides, and the communications data set, where volume information is kept and more than one SMS instance can talk to other SMS instances in the same sysplex. So we need to know the names of those data sets, of course. There's normally not much reason to change these things. The device statistics read interval, how often is the communications data set updated? Actually, that's interval, and then the device statistics read interval is how often do I go out to the DASD volumes and read the devices and update the internal control blocks. One that might be of importance for security purposes is re-verify yes or no. Whether when I check the user's authority to be assigned a particular storage class or management class, normally the storage class and management class, whether a user is allowed to use those, is checked at the time the job is interpreted, at the time it's submitted to the system. But it might also be checked at execution time. If things spend, for example, a long time in a queue waiting to be executed, or maybe for JES 3, you might want to look at specifying re-verify equal yes to check the management class authority at execution time as well as at interpreter time. SMF time, by default, when do I write an SMF type 42 record? There are a number of SMF 42 subtypes that SMS writes, mostly having to do with record level sharing and transactional VSAM. And so when do I write those? Do I write those at the SMF interval, or do I write them at the other intervals that might be specified in the IGDSMS parameters, cache time and coupling facility time? The default is just to cut the SMF 42 records at the time I cut other SMF records. One that's important, and the default for some reason is still 8 rather than 32, is the number of systems in the SMS plex. If you set this, and it cannot be set by command, it has to be set in the PARMLIB member. If you change it, you can only set it upward. You can change it from 8 to 32. And it's a very old default, and so if you've got more than 32 systems, which is now not uncommon in your SMS plex, you may need to, well, you've got more than 8 systems rather, then you may need to set this to 32. And this actually changes the format of the records in the SMS configuration. So it is a one-way change if you make that change. You can't fall back from a 32 system to an 8 system value. But if you've got a large environment, you may want to look at changing that. Okay, let's talk about then the next category, which is ACS routine related parameters, things related to the ACS routines and what they see and what they execute. One that some installations will set is ACS defaults equal yes. If you take the default of ACS defaults equal no, there are certain variables, and this eliminates a RACF call if you leave it at ACS defaults no. But if you specify ACS defaults yes, certain ACS routine variables become available because a RACF call is made for the particular user allocating the data set. And so certain RACF variables, the application name and default data class, default management class, default storage class, that is from the RACF defaults for that user, become available in the ACS routines. If you're not using those variables, there's no reason to set ACS defaults no. We talked about log writes and ACS routine debug. A lot of people aren't aware that there are actually user variables you can code or you can reference in the ACS routines. There are 3 user variables, user underscore ACS var 1, 2, and 3, and you can set the values. And so this is useful if I want to know if I'm running on a particular system or with a particular value of some type. I can set those values in the IGDSMS member. And I can set this again by command. I don't necessarily have to put it in IGDSMS. I can issue a SET SMS command if I wanted to change the value. One other thing that is related to RACF is the use resource owner, yes or no, and the default is yes. And when we do when RACF does its checking for is the user allowed to use this management class or storage class, what user ID do I check against? Do I check against the allocating user ID, or more commonly, I check against the resource owner? That is typically the high-level qualifier is used. So if the SYS1, I see if the resource owner for SYS1 has access to this particular management class or storage class that they're trying to assign. So there's a bunch of other parameters related to how data sets are allocated, and these are the ones that are probably the most of the most interest for the storage administrator. Probably the biggest of these is, am I going to use extended addressing volumes, yes or no? If I want to use EAV volumes, that is volumes more than 65,000 cylinders in size, I have to specify use EAV equal yes, and I could take the default breakpoint value, where I can specify a different breakpoint value, which says how large does the data set have to be before it's allocated into the cylinder managed space. So if we're going to use EAV volumes at all, we have to turn on use EAV equal yes. And this breakpoint value is only used if there's no value specified in the storage group. You can also specify the breakpoint value in the storage group. One that's really sort of useful, and maybe you should consider turning on, particularly if you've got a very large number of volumes or you run into out-of-space issues, is fast volume selection. The default is off, and when an allocation occurs or an extend to a new volume occurs, the direct access device space manager, DADSM routine, has to go out and decide which volume to allocate to. And it has a rather complex algorithm about deciding whether this volume is over its limit or under its limit. And so if more than 100, turning fast vol cell selection on says, if I've gone and looked at more than 100 volumes and all of them were rejected for insufficient space, that is, I couldn't allocate to that volume without going over the limit, then I won't bother actually looking at volumes. I won't bother actually going to the VTOC and looking at the volumes. I'll use the in-storage SMS volume statistics. And so this can be useful if we've got a lot of fragmentation. In fact, it changes the volume selection algorithm. In fact, it's the volume for a striped data set. fast volume selection algorithm is automatically used. So it might be worth turning on fast volume selection if you've got a very large number of volumes and there's a lot of fragmentation going on. Another place you might want to consider doing that is the use most free space parameter. The default is no, but when I allocate a data set, SMS is going to try and choose the volume that is most appropriate, and if it will come up with a group of volumes in the primary list that I can allocate to without going over the limit, or if all of them, if I have no volumes in the primary list, everything's in the secondary list, do I choose the volume with the most space, or do I choose a volume randomly? If I choose the volume with the most space, I have a better chance of getting my data set allocated, but I will also tend to force all the allocations towards that volume. So it's a two-edged sword there. A couple of other just sort of limits. MaxGen's limit for version 2 PDSE member generations. You have to have for PDSEs, you can have version 1 or version 2, and the version 2 PDSEs support member generations. What's the maximum number of member generations? And for some reason, they made it 2 billion as the highest possible. You might want to set that lower. Another default you should probably consider changing is PSEXT version. The default is 1. When I'm creating a sequential extended format dataset, I have two flavors I can create. I can create version 1 or version 2. Version 1 is the older form of sequential extended format datasets, and we can get into problems with flash copy of multi-volume datasets if some of them are on version 1 sequential extended format and some of the volumes are on version 2. Basically, you can't do a multi-volume flash copy. There's no reason really not to specify PSEXT version 2 and make all sequential extended format datasets version 2. You can, if you're having problem with HPF IO, high performance FICON IO, you can turn that off, but normally there's no reason to do that. Another thing, this one has actually been updated, and it sort of has what I would consider the correct default for block token size. When large data sets, DSN type large format data sets first came out, you had to set a value in the DCB extension to say, I understand large format data sets and I can use them. They're so common now that IBM has removed that requirement or has allowed you to ignore that requirement. And the default is I don't have to actually set an option in the DCBE to support large data sets. CA reclaim, do I want to reclaim unused control areas? Usually you want to set that in the data class, and so that's the default. What if I'm in terms of compression, what's my default type of compression if I didn't specify it in the data class? Do I use tailored or generic, or do I use the ZEDC? And finally, one that's kind of interesting but occasionally can be confusing because there's a number of very similar parameters, DSN type. If I specified directory space, that is, I specified space equal some value with the directory value, but I didn't specify DSN type, the default is I get a PDS, which in most installations is what people use. They use partition data sets for everything. But if I want to make a PDSE the default when I specify directory space, and instead of a PDS, and so I want to use PDSEs on a large scale, I can specify DSN type library so that if I specify directory space but I did not specify DSN type, I get a PDSE rather than a PDS. If you want to start really using PDSEs on a large scale, DSN type library would be the thing to do. Some other dataset related parms, normally we don't need to fool with these too much, but GDS reclaim, if for some reason you're having a problem with generation datasets, you can turn off GDS reclaim, which says I don't want to delete unused generations. One that you might want to consider turning on, though, is honor DSN type PDSE. And so this is, again, a little confusing because it's very similar parms, but if you specify DSN type equal library, but you didn't specify directory blocks, and you didn't specify DSORG. So if I've specified DSN type library, but I didn't specify any directory blocks, and I didn't specify DSORG PO, do I want to create a PDSE? Probably I do, but the default is no. So honor DSN type PDSE says if I specify DSN type equal library, then I really meant library and allocated a PDSE even though I didn't specify partition dataset or directory blocks. If you've used a lot of what used to be called tape mount management, where small tape datasets were redirected to disk, you might want to turn on override expiration date yes, which says for an SMS managed dataset, which has an expiration date, and you don't see those too often, but it is possible to have DASD datasets with expiration dates in them. Do I want to ignore that date and allow the user to delete the dataset even though they didn't specify purge on the delete? And so that's sometimes useful if you happen to have a bunch of DASD datasets with an expiration date on them, and you don't want to honor those expiration dates. You can say override expiration date yes. There's a few sort of special purpose parameters in IGDSMS for message suppression. There are certain messages, IGD messages, SMS messages, that can come out really frequently. And so you may want to turn those off. And so IBM has actually gone to the level of saying, I want to suppress these messages that normally come up at this, for delete or rename. Very often a disaster recovery site, you'll see something like that. If I'm trying to delete or rename a dataset and the dataset's not on that volume, perhaps because it was an alias, I would normally get message IDD 17054, or a dataset was allocated to a multi-storage group, or a dataset was allocated in the same storage facility. You might see a lot of these at a DR site, and they can flood the console, so you can turn these off just by suppress _ SMS message or DR message. One feature that a lot of people aren't aware of is IGDSMS 00 volume selection message. There's also some tracing facilities, SMS tracing facilities, which are mostly used by ISVs. IBM, if you're having problems with SMS, the level 2 folks might tell you to turn on the trace. But what's really important is the volume selection message. If you're having difficulties with volume selection message, with volume selection, with choosing the right volume when a data set is allocated, there is a facility where you can actually trace the volume selection. IBM will tell you for each volume whether it was selected, and if it wasn't, why it was not selected. Unfortunately, they sort of conflated both the trace and the volume selection message parameters together. So the same filters and the same type and trace parameters are used for both tracing, SMS tracing, which normally is only used by IBM level 2, and volume selection message. So the most important of these is set vol cell message, and I can set it on or off, or I can set the number of volumes I want to see in the message, because I might have several thousand volumes that could be considered for allocation. I probably don't need to see them all in the messaging. And do I want these volume selection messages to come out for all allocations? No, I probably won't want to see them mostly for allocations that fail, because those are the ones I'm interested in seeing the volume selection trace. And I don't want to trace every allocation, so this is usually used for reproducing a volume selection error. So I can filter it based on ASID or job name or step name or dataset name. And so usually I would set these via an individual SET SMS command. And again, because both the volume selection and the trace parms use the same syntax, it can be a little bit confusing how you set these. Normally, if I want to do some volume selection message tracing for a job or a step or a dataset name, I'll issue a SET SMS command that says vol cell message on and either all, or for usually all, because I want to see all the messages. I might say type error. I only want to see jobs that result in an error, but for this particular job and this particular step and this particular data set. And I don't have to specify all of those, but I have to specify at least one if I want to see the error messages. It is possible, there's a bunch of abbreviations you can specify, so that if I wanted to say, I want to see both volume selection and SMS module tracing for a particular job, I could set job name, select job, volume, trace job, trace. So there's a bunch of these that I could set, but normally it's vol cell message on, and the particular type and job name. If it's useful once you set this, you may want to say, I want to display the volume selection trace parameters. So I can say display SMS vol cell message, and it will show me what volume selection tracing I have enabled. It's a little easier to see in an example. So let's take a look at an example. There are two types of messages that come out when I turn on volume selection tracing, a summary message, a set of summary messages rather, and a detailed message for the actual allocation of the data set. So the summary message, the IGD385I, tells me for this particular data set, this is the volume selection criteria. Vol cell message on, I want to see all of the messages, not just particular ones, for both error and non-error allocations, type all, for this job name, for this ASID, for this step name, for this DS name. So this is the volume, this is what I get out of a display vol cell message. And the IGD messages are nice enough to tell me a little bit about the ACS routine variables that are being used, the DS type, the storage class, the data class, is it guaranteed space, how much space. In this case, there was one candidate storage group, and 4 volumes were rejected because of insufficient space. And then we get the detailed analysis. Says, well, this particular data set was assigned to pool storage group STG1, and for every volume that was considered for allocation, for SMS7, for SMS3, for SMS4, we get a message that says, did I allocate to this data set? Was it selected? Or did I not select it, or did I reject it? So with the first parameter in the first subparameter in the after the volume serial number is, did I select it? Did it not get selected, or was this volume rejected for some reason? If it was rejected, I'd like to know why it was rejected. And so there are two other subparameters following each volume. The first one is the selected or not selected. The second one is 5 bytes of preference flags. And these preference flags are the volume was under limit or over limit. It was capable of dual copy or not dual copy. All the flags are documented in the IBM manuals. And if the allocation fails, then there's 4 bytes of failure flags, followed by 4 bytes of diagnostic information. So there's a lot of volume selection information about why was this volume chosen or why was it not chosen, which is probably more important, that I can get by turning on volume selection message tracing. Okay, there's a bunch of other parameters having to do with PDSE, some of which we've seen. There are, in fact, quite a few of them, because you can set individual values for both the PDSE address space, which is the traditional address space that was used for PDSEs, and for PDSE1, because there are 2 different types of PDSE address spaces present. This particular panel, which shows all of the PDSE-related parameters that you can set in IGDSMS00, is actually part of the Sync Sort Storage Management SMS debug product. So if you're interested in that, you can get these sorts of panels and update the SMS configuration from ISPF and see what all of these excuse me, mean in real time. Similarly, there are a bunch of options having to do with SMS VSAM, and there's a whole bunch of them, because you can set values like how much record level sharing above this bar virtual storage should I use for each of the 32 individual systems that might be specified, that you might have available. And should I start the SMS VSAM address space for record level sharing? So there's a whole bunch of record level sharing options that we won't go into, but this is what makes the IGDSMS00 members so large is that you can set individual options for things like PDSEs or for regular level sharing, and you often may have to set it for each of the systems in the SMS plex. There's a similar set of variables for that relate to transactional VSAM. What's the transactional VSAM address-based name? How often should I do the SMF type 42 records? A lot of things having to do with what should be the timeout before I can and how long should I lock if I'm writing to a transactional VSAM. And transactional VSAM and RLS all have to do with doing multiple concurrent writes to VSAM datasets. And similarly, for the same purpose, there's a bunch of variables in IGDSMS00 that have to do with CICS and what are the control string names and what's the prefix for certain types of CICS datasets. So there's a lot of items in the IGDSMS00 member. In fact, there are several other members, and all of this is documented in the MVS initialization tuning reference. All of the SYS1.PARMLIB members are in there, so not only IGDSMS00, but you may want to look at the allocate member, the IGG-CAT member, and the device support member. Or you may want to look at the MVS system commands for display and SET SMS commands, and all of the volume selection, diagnostic information that we looked at, we can find in the DFSMS DFP diagnosis guide. So there's lots of documentation on this stuff. So that concludes our trip through IGDSMS00. If you're interested in learning more about SMS, we have some additional webinars and blogs. We'll be starting a blog series this month on storage management. And so if you're interested in any of the SyncSort storage management products, certainly give us a call here at Precisely. And we're always interested in what are the pain points or the problems in your system, because we'd like to find out what our customers need help with, and if we can, provide software and support to do that. Thanks again for listening, and my name is Steve Pryor. I'm Principal Technology Architect here at Precisely, and we'll see you on the next webinar.